everybody. So we're going to be talking about how to use R for some of the basic things we need to do in statistics, okay? And the first thing is we got to talk about data frames, all right? So data frames are very highly structured and they're structured in R so that we can do certain things with them that we need to do for statistics and data science. The main thing is the columns of a data frame are different variables, and the column titles will give us an idea of what that variable is, whether it's age or whether it's number of credit hours taken in college. There's something in there that can also be categorical, like we have freshman, sophomore, junior, or senior. So the column title will tell us what sort of data is in that column, and then each row is an individual from the data, from the research data. Okay, either a person or the lab rats or the houses that were being studied, whatever the individual of study is. Okay, so how do we import it? Well, we use read.csv. Um, Also, we're going to use the head function to provide us a summary of either the data frame or the vector we're looking at. And one of the main things we're going to be doing is subsetting. We have to be able to focus in on particular areas of the data. Um, in a large data set, there may be 1,000 different statistical questions we can ask. So we have to be able to focus in on the part of the data that will allow us to develop an answer to the specific question. Sorry. So loading the data into R, and you can see all we do is use read.csv and we put the URL where the data is stored if it's stored online. If it's stored in the same folder as my notebook, I can just put the file name, right? You see the file name here at the end is personality.csv. Again, if the data file is in the same folder as the notebook, you can just put read.csv and the name of the file in quotation marks. All right. For this class, I tend to use my faculty webpage is a place to store things. Um, and then the head function, right? It defaults to 6 rows, but this one where I've used it here, you tell it the data frame you want to summarize, and if you put a number in, if you put comma 5, it'll show the first 5 rows. And it means data rows. It will also show the column titles, but that doesn't count as one of your 5 rows. All right, so we've got 3 methods that we use for subsetting. And wait, I have a typo right there. Um, the $ method and the row column method, and we can use the subset function. Now, it turns out this is the most sophisticated one, and but it's really useful when we have to ask compound questions. And you'll see that in just a second. The first one we're going to go over is $, but notice what we've got here. We're assuming that we have the personality data set already loaded using read.csv. And if we have that, these examples will make sense. So we've loaded this, and we're going to show you how to subset the data frame pers. Right, getting rid of the highlighting there. And here you go. So if we're trying to extract the perfectionism column from the personality data set, what do? We just use the table name, the data frame name, then we put a $, and then we put the name of the column title of the column we want to see. And this takes the whole data frame, which has almost 40 columns, and just extracts the one that we want. We can also do this with what's called the row column method. It's called row column because I can specify some things here for the rows and I can specify some things here for the columns. This is very much like MATLAB or our matrix notation, right? Where the first thing we list is what row it's in and the second thing we list is what column it's in. And if we have a matrix A and we're talking about the element A sub ij, right? I is the row that it's in, and J is the column that it's in. So we always go in that order, row column order. And this square brackets notation, right, specifies to R, hey, I'm telling you what to do in the rows and the columns. However, um, and this won't work. Why? Because the P is capitalized. Um, but the column title is capitalized. I used a lowercase p there. But you just do purse, the table, the data frame name is purse, and then the square brackets, and just leave the row area empty. Just put a space there. It's fine. Why? Because we're not doing anything with the rows. We're just specifically looking for the perfectionism column. All right. So those are the two, and they're pretty straightforward, and they work really well. It turns out that the row column method will actually allow us to put more than one column in here, so we can get 3 or 4 columns of data using this. And we'll show you that going forward in the class. So it's a little more flexible than the dollar sign. I'll tell you what, the dollar sign method is very fast. If I just want that one column, excellent, excellent use there. Also notice the assignment operator, right? In our best practice is to use the left arrow assignment operator. Now, we're used to using equals, and equals will work in a large majority of the cases, but there are some subtle differences between what the equal sign is doing and what the assignment operator is doing. And again, best practice is use the left arrow. I sometimes, I code in some other languages where we use the equal sign, and so I sometimes in R forget and use equal signs, and it's not a fatal error. Again, best practice suggests we should use the left arrow for the assignment operator, and then we get to the subset function. And you're like, why have we been subsetting with 2 other functions and not the subset function? Well, it turns out that the subset function is for more sophisticated situations. Now, and it's a little clunky, let's be honest. You see here, subset, I give it the name of the data frame, and then I say select equals, and I tell it whatever column I want. This will again just extract the perfectionism column from the purse data frame. All right. But it turns out this is like, you know, this is like hitting you're trying to hang a picture, and, you're hanging a little picture, and you're hitting that little nail with a sledgehammer. You don't really need something this powerful to do this when, you can just do, the purse and then the dollar sign and then perf. It's so much faster to use one of the other subsetting methods in this case. But I showed it just because that's the same operation we've been doing in the other two. And so now here below, let's say we've got 2 criteria, right? So now we're looking at 2 criteria. We want biological sex to be female, and we want age to be at least 20 years old. Okay, now you can see, look, the ampersand is a way to do, is saying and. Both criteria have to be true. Both X and Y criteria have to be true. Now, by the way, we have or. Or is just a vertical line. Okay, so we can say I want people like this or people like that, or I can say I need people like this and people like that. So I've got the option with logical operators to do it. And by the way, when they're both in the same, well, you can get some compound strings of these, and it can get a little confusing, but we'll use some parentheses and so forth to keep our groups together. But what does this do? This answers the question, right? We do have sex to be female. And again, when we need something to be exactly equal to, we're using the double equal sign, right? That is, right, ensure that the thing on the left is identical to the thing on the right. um, it's sort of like a question mark. Is the thing on the left identical to the thing on the right? And if the answer is yes, it's going to keep it. The subset function will keep it if it's true, if it evaluates to true. If it evaluates to false, if the sex is male, for example, and it evaluates false, it will discard it. Okay, so when this one is actually true, evaluates to true, right? It'll keep it. Same thing here. This age greater than or equal to 20, this is a question mark, right? Honestly, it's a true false operator, right? It is giving us a true false, but again, when the value in the age row is equal to 20 or greater than 20, this evaluates to true and it's kept. And if the person is, say, 18, then it evaluates to false and it's discarded. Okay, so inside the subsetting functions, we're making statements that can be either true or false, and then all the trues are retained, if that makes sense, okay? And then we get to the category function, excuse me, the cat function. Okay, so this works like a print function, and it'll print text, it'll print the contents of a variable, right? So if we have a variable v that equals 20, it'll print the 20, not the v, when we ask it to print that variable. And it can also do calculations, so we can calculate the standard deviation right inside the cat function, rather than creating a variable outside the cat function and calling it inside, calling the variable name inside the cat function. So um, it's a really useful thing. And let's look at an example. Okay, once again, suppose we have the numeric column vector perf. These are the perfectionism scores from the personality data set, right? And look, a couple of things that I want you to notice. First of all, we're calculating the average right inside the function, right? So I have text. Here's text, the perfectionism scores that U and G have. Now notice this. This is important. Okay, so that's a hard return. So I'm formatting this um, inside the cat function. I'm formatting it so it fits on the screen, but also making the point that we can do this. R is going to ignore all the spaces and returns inside the cat function, right? So I can actually kind of format inside the command however I want to make it more visually appealing. Um, and here, because I needed to fit it on the screen, but also kind of show what's going on, right? The hard returns are happening with the backslash n's, okay? The output has hard returns only when I put in the backslash n's, all right? And this is text, right? So it's going to do a hard return and then leave a couple spaces on the second row, then have mean equals and a space. And then it's going to put in the average. Again, now I've separated with commas, so I'm back to putting in text. And there needs to be a close quotes here and a comma before the standard deviation for perfectionism. Um, but But yeah, so what you want to do is remember that inside the command, R is ignoring all of these spaces and hard returns that you put in the command. So that does allow you to throw some of those in just to format the command block, the code block, so it's readable. Um, but the output is only going to have uh, hard returns if there's a backslash n within the text portion of the command. All right, so again, examples will help you learn how this goes, but the cat function is very useful. So now let's jump into our notebook one. So this is notebook one, and by the way, I've created a whole new little portal for these intro to statistics videos. All right, so the commands will work and will load it, but it's not the same Data Hub portal that all the other statistics information is in. And if you hit the little folder button over here, you're going to see that you'll have a 3350 folder and an intro folder. And the intro folder is actually where these files are stored if we need to access them later. So what are we going to do? These are the tasks we're going to work on: importing data, subsetting the data frame, and calculating some basic statistics. So this is a link to my web page where I have a bunch of data stored. All right, and that's essentially what we use in this class. And you can see here, I've provided the text just so we can get this going. All right, so what is our first example? We're going to use the read.csv function to load the personality data frame, and they give us 3 tasks. We're going to load the data frame as pers. We're going to extract the column from perf into a vector, a numeric vector called perfect, and we're going to find the mean. Okay. Import code goes here, so read. Oops, I've got the all caps on for some reason. Read.csv, and I want to put quotation marks in, and I'm just going to copy paste. This is why I provided this for you. Copy paste the text in here, and what happens? And it looks like nothing has happened, right? But if I do this, right, it'll show the first 6 rows. Now, it defaults to 6 rows. If I just want to show a little less to use up a little of the screen, a little less of the screen, I can do, say, pers.4. It'll show me the first 4 columns, and you can see a lot of data here. Notice that it has done the ... dots. It's not showing everything. And that's a problem we can overcome. It is even trying to simplify the output for us. Okay, so we have it loaded. Now we have to extract the perfectionism data into the vector called perfect. And how are we going to do that? Pers $perf. And what am I going to do? Well, let me just do perfect, and you can see why. Well, it prints out the whole vector, but it's a column vector, but it prints out as a huge row, and it's breaking the rows. And so it's not that hard to do. If it were longer, we might use head, and if we do use head, it simplifies it and shows the first 6, right? Or we can show the first 10, right? Or if it's a small vector, we can just show the whole thing, sorry. Okay, and then we want to calculate the average. What are we going to do? Well, the average is mean, so I just do mean of perfect, cha-ching. And the average perfectionism score was about 108. That's how it works. It's not hard. And again, I've got to admit that I use the $ a lot. Why? If I just need to extract a single column, it's really fast. It's hard to beat it for how fast it is in that specific situation. Now, example 2, we're going to use read.csv to load this meteorite data. Okay, and we're going to load it into the variable met, and we're going to extract the mass column from it using the row column method, and we're going to find the mean. Okay, we can do all of that. All right, and what I'm going to do here is I'm going to use read.csv, and I'm going to copy paste the personality data set that I still had there. Why? Well, because everything is the same, right? It's all stored. This is my faculty webpage, faculty.ung.edu/rsyn/data. That's where all the data sets for my classes are. So that part was the same. All I had to change was the file name. Even the file extension was the same, right? So, and then let's real quickly do head met, and it doesn't like something. What did I do? Interesting. Okay. So what I'm going to do is I'm going to jump in here to the, oh, I'm sorry, I wanted to do this. Will this pop open? Okay, so you can see it popping open, and I'm coming here to get the world airports And what I want to do, I want to copy this link address. Why? Because I've got something jacked um, in this call. So what I'm going to do is come in here and I'm going to paste this thing. Oh, that's the airports. I wanted the meteorites. Dang it. So go in again and go get the meteorites. Again, click on that, get the copy link address. Come down here. And it's meteorites underscore NA. That's what I forgot, the plural and the NA, all right? So when I put that in, it should work. Oh, and now it's telling me I've got two .csvs, which makes sense. It only needs one file extension. Good grief. Really made a mess of that. And that again, that's why I want to use copy paste as often as I can, because typing these in, you have to get it exactly right. Okay, and just to calm this down a bit, let's try MET3, head MET3, so I don't have quite as much stuff. All right, and the mass column is lowercase mass. All right, and I'm supposed to get, oh, and this is still perfect, huh? So this is supposed to be mass. All right, and what am I going to do? I am going to extract it using the row column method. So that's going to be met square brackets. Then I have a space for the row, then comma, and then column. What do I want in the column? I want the mass function. I want the mass column. And that's done it. Let me hit return. And I don't know how long this how long this file is. So this is why we want to use head sometimes, even with a vector, right? The vector, when there are a couple thousand things, right? It's um, pretty hard to read. Also, it has some scientific notation in it. So this is where we might go head, mass, and let's do 25, right? Just do a summary that's reasonable. We can still see what kind of data we have, right? But it's much more simplified. So that's what we're using the head function for. The head function is just a summarize function. Just summarize this thing, this vector or this data frame. And then the average will be calculated the same way. I'm going to do mean of the mass. Oh, wait. So this hashtag space in a code cell is a comment, right? So I'll do it down here. I'll leave the comment in, do mean of the mass. All right. And the average meteorite weighed 123,000 kilograms, which is kind of heavy. It's like 250,000 pounds. Um, and again, I don't know if that's a big number or a small number in terms of meteorites. I wouldn't want it landing on me, that's for sure. Um, okay, and then to load the skyscraper data frame, and they're asking us for the variable sky, and then to get all the buildings that are 1,000 feet tall or taller, using either the $ or the row column method. This is one of those situations where the subset function is really going to help us. But let's do it. Let's do it. So we're going to do read.csv and sorry. I'm going to have to do this again. Sky equals read.csv. And my faculty web page is https://faculty.ung.edu/my name, RSIN, RISNN, /data, and this is Skyscraper, and I think it's version 2. Yeah, there it is. Skyscrapers v2.csv. close quotes, close parentheses. Let's do head sky and just see what we've got. Okay, so we have the material it was built out of, the name of the building, the city it was built in, the year it was completed, and the height in meters. Okay, now they're saying 1,000 feet tall or taller. Okay, and by the way, I'm not sure there's an easy way to use the $ method or the row column method. That's a copy paste from up above. I'm going to use subset, right? So I'm going to get tall. What am I going to do? I'm going to say tall is subset of the sky data frame, right? So that always starts. I say the subset function and then the name of the data frame I want to take a subset of, right? So what do I need? Um, and all I need is 1,000 feet tall, right? So what am I going to do? I'm going to go to height greater than or equal. The problem is the height is in meters. And I know there's a little more than 3 feet per meter. So I don't know exactly how tall 1,000 meters, I mean 1,000 feet is in meters. I'm going to do this. I'm going to do, let's say 350 meters. I'm going to say that's approximately 1,000 feet. Okay. And it does it, but to print this out to see if we got it right, let's do well, yeah, six rows will be enough. And notice that we're seeing only things above 350. If we looked at more of this one, we would see that there's definitely some skyscrapers in here that are smaller than 350 meters. Okay. And then it asks us to find the mean. And again, just to show what we're looking at, I can do cat the average height of skyscrapers that are 350 meters tall or taller is, and I'm going to throw in a \n and a couple of spaces. I'm going to do mean of tall, and then I'm going to close the cat function. Oh, I see. I've subsetted the table so I have the right heights, but I don't have just the column of height. Okay, so let me do that. And it doesn't matter where. Let me put in a select equals height and height equals 350. I thought that was an ampersand, sorry. Okay, so now, well, it's sort of doing what we would hope. Sadly, these are the numbers of those data frames. I am not getting really lucky here. So what I'm going to do, I am going to use subset in a second. So the first thing I'll be doing is do temp. What is temp going to be? Temp is going to be sky $height. Why do I want that? Sorry, I'm hashtagging here. Okay, so I have all the heights in meters. Okay, and now what I'm going to do is I'm going to create the right thing. All right, I'm going to do tall equals subset, but now instead of subsetting sky, I'm going to subset this temp data frame that I have. I'm going to do height greater than or equal to 350 meters. And then I'm going to do head tall just to see that I'm actually getting a numeric vector. What doesn't it like now? Um, how about this? um, let me show you what I'm going to do. Wasn't expecting this to be quite so frisky. Okay. Um, if I just do tall in the subset sky, I get a data frame. The problem is I don't want a data frame, but what I can do is I can take the $ height and add it in. So this subset function returns a data frame from which I can extract the column. Now I've already sorted the column to have only the values that I need. And then everything works, and now you see the cat function also working with the hard return. And one thing I might want to do down here is actually say average equals, put a space, and then put mean. So again, I can format the text however I want to make the to make the output come out in a readable way. Okay, that was exciting. Let's jump into the second notebook, and we have some more tasks to complete. Okay, so here we are, and the first example we have is narcissism, and we're supposed to take from the personality data set and determine the overall average narcissism level for these UNG alumni, then compare the narcissism levels between females who are 20 years old or older to that of males who are 19 years old or younger. Okay. Well, okay. So we got three different things, three different subsetting tasks they're going to have us do. The first thing they want is we need to, first of all, get the read.csv, right? So read.csv, and we've already done this one. Faculty.ung.edu /rsyn/data. Well, it's actually / personality.csv, close quote, head 3. Okay. And you've seen this one before. Okay. And the narcissism variable is way over here, and it's capital N narc. All right. So that's what we want. All right. So, okay. Let's just go capital N equals pers $ narc. And I can just show them, right? And these are all the narcissism scores. Okay. And we were using the N16, I think. So 16 is the maximum, 0 is the minimum. And we don't have anybody approaching the maximum here. All right, so what do they want? The overall average narcissism level. Okay, so mean of N. Okay, so the overall average at UNG, and I probably would need a cat function to remember this, right? So cat text, the overall average narcissism score at UNG, and let's just say it's 2012. It was approximately then that we collected the data. The overall average narcissism score in 2012 was, and again, I'm going to actually just put in another text box here, what, with the \n, space, two spaces. I'm going to say mean equals, and then I'm going to calculate the mean, and then I'm going to close out the cat function. It didn't seem to like that. Let me not split these. There we go. I'll have to think about what was going on there, but we've got it how we want it, and now we know, we've got the text that'll remind us what was there. But now what do we have to do? Okay, well, we have to subset the n in a way that we can get, okay, so we need to have females who are 20 years old or older, so let's call that F. And what am I doing? I'm going to subset the personality data set with sex equal to F, and that's text, right? The F character is text. And so biological sex is female, and what do we want? We want age greater than or equal to 20. And again, this will be a data frame. Let me do head F. Let me summarize the data frame F. And it thinks it's a data frame, but we're not seeing it all. I'm a little confused as to what it thinks it's grabbing. Okay. Interesting. Because the subset should return a data frame, right? And it thinks it is, but I guess it didn't have any data in it, which I'm finding a little odd. So let me pause this for a second and see if I can figure out what I did wrong. Okay, this was silly. I put a comma between the two criteria. It has to be an and. They both have to be female biological sex and age greater than 20. Oh, and there we go. That is the correct subsetted score. You notice that there aren't any teenagers in the age column. Sex is all female, right? So this is doing the correct thing. Okay, now what? Well, now we want to extract the narcissism column, right? That is weird. Oh, F and I need $sign. There we go. There they are. Those are all the narcissism scores. And then what can I do? Right? I can take the mean of F. Actually, let me just put it up here. Mean of F $narc. Sorry, I've got a few things to remember myself. So the mean for the young women is what it is, and then it says we had to find that of males who are 19 years old or younger. What am I going to do? I'm going to copy this. Why? Because I'm still subsetting the personality data set based on sex and age. Sex will be M instead of F. And here I want less or equal to 19. And I don't want that to be F. I want that to be stored in the data set capital M. And for the moment, let me actually print out a summary. And we'll see how we're doing here. Oh, good. For the first time in a long time, I didn't throw an error. And you see it does show me this data frame. Now we have males as the sex. Notice they're all teenagers, right? And it does give me the mean. Let me if I put a semicolon in there, will it, I'm sorry, put it in the wrong place. If I put a semicolon there, nope, it's not suppressing the output based on so semicolon, so let me just throw it away. Oh, and I need an M there. There we go, and now we can see the difference, right? So The older females are slightly less narcissistic than average. The younger males are more narcissistic than average. And I'll tell you what we know. We know that narcissism values decrease as we get older, and it's just how the way we are when we're toddlers, right? The world does revolve around us. We're very self-absorbed and self-centered as young children. And most of us, that goes away as we get older. Again, you know some 20-year-olds perhaps, or some 40-year-olds that are a little more self-absorbed than the average, right? Um, but it turns out, at least at the college age, what we've found at UNG is that generally speaking, males have slightly higher narcissism levels than females, and older students have slightly higher narcissism values than younger students. So we're doing both of those things here. Airports and elevation. Find the average elevation of the airports, the heliports in Kansas, and airports and heliports in Kansas. Compare them. Okay. This file name, so I've messed this up enough that I am going to grab this text, right? And I'm supposed to call this thing, or I can call it whatever I want. Let's call it air. And again, I've been using equal signs instead of the correct assignment operators, but they say that this file name will be airports. CSV, and let's do head air 3. And I can't use both of them, right? Just have to use one assignment operator. And we see that we have the latitude and longitude of the city. So we have the GPS coordinates, the city that it is in, the region. So we have USPA, that's Pennsylvania, Kansas, Alaska. And we know whether it's a big airport, small airport, or heliport, okay? And the cool thing is we know the number of feet above sea level it is. All right. So what do we need? We want to look at the descriptive statistics, including a 5-number summary from the heliports in Kansas, and do the same thing for Georgia, okay? Well, so what am I going to do? I'm going to do KS for my Kansas, right? And I'm going to subset first. Subset what? I want the, first of all, I have to tell it is air is the data frame, and I don't have to put quotation marks around the column titles. Why? Because inside the subset function, you have to tell it what data frame you're working with, so it knows it's working with a data frame. So all I have to do is type region equals equals, and notice that the region is US-KS. Okay, so this is all the Kansas airports and heliports. And then what am I going to do? I'm going to do $ elevation underscore feet. And I'm going to do head KS just to see if I'm getting what I want. And it didn't like it. Oh, this has to be in quotation marks. What it's looking for inside the cell has to be in quotation marks. The column title is the thing that doesn't. And you can see that there are a lot of Kansas heliports, and maybe these values are a little more expected, 1,100 feet above sea level, but there are some surprising numbers in there, okay? But we are getting the values out of Kansas that we want. So what am I going to do? I'm going to do a cat function, and so the standard descriptives for Kansas airports, Kansas airport elevation is as follows. Okay. And I am going to start with the \n12. I'm going to do mean equals, stop the text, start the mean equals KS, right? And then I'm going to start the text again with a backslash going to the next row, standard deviation equals, close off the text, comma, SDKS, KS, comma, um, and again, if I want, I can use um, hard returns inside the command that aren't actually going to show up, right? And what I'm going to do here, I'm going to do sample size. Sample size equals, I'm going to do length of ks. So it's going to tell me how many odd items are in the vector, which is my sample size, okay? And then I'm going to do two text characters, two hard returns as text characters. Why? Well, because, and I need to put the, text, okay. The 5-number summary for, well, is as follows. I'm going to close that off. And I'm going to close the parentheses and do what? I'm going to do summary KS down below. Why am I doing this down below? Well, it turns out that inside the function, see, the summary function is created with these titles. Okay, it's actually a data frame with titles and the values. So I can see the minimum, the first quartile, which is the 25th percentile, the median, the third quartile, which is the 75th percentile, and the maximum, right? But what happens if I put it in here? Let me just show you. And then close parentheses. And it prints it out, but it's taken away those titles. Inside the cat function, it's cat's like overriding the basic output format, right? So that's why I would like to do it outside. And I'm just going to say the 5-number summary, cha-ching. Oh, and we probably do want to throw in a hard return. And there you go. Okay, but now we want to do all this for Georgia. Okay. And if I'm going to do it all for Georgia, then I want to create the GA and USGA caps. Okay, this will be Georgia mean of GA and summary from GA. All right, so I'm just making the changes. I copy pasted for Kansas, made changes, all the KS's become GAs. Now it does the exact same thing. And notice that the minimum elevation of our airports is 4 feet above sea level compared to 750 feet above sea level for Kansas. Well, that makes sense. We have a coastline. So maybe the airports and heliports in Savannah are much lower than the lowest elevation airports in Kansas, right? Also notice, the 75th percentile is nearly 2,000 feet, where ours is 940, and the maximum in Kansas is higher elevation than the maximum in Georgia, even though we have the North Georgia mountains. And what's going on there? Well, western Kansas isn't exactly as flat as the rest of the state. Why? Well, western Kansas borders eastern Colorado. Now, the Rockies don't start until, 100 miles or so into Colorado, but eastern Colorado and western Kansas are not just flat. And the elevation is increasing as we get closer and closer to the eastern slopes of the Rockies. But anyway, I just like this one because it's an interesting juxtaposition of Georgia compared to the values for Kansas. Okay. And then in the skyscrapers data set, find the descriptive statistics for all steel buildings built after 1960 in Chicago or New York City. Wow. Oh, and they wanted a density plot. I'll show the density plot on this one. Okay, so what are we going to do? Well, the first thing I'm going to do is grab this, right? And okay, so I'm going to call this sky, and I want skyscrapers underscore V2. Is that how it went? I have to admit, I'm forgetting. Yeah, skyscrapers v2.csv. Yes. Okay. And again, let me go ahead, sky 3, just to see, to make sure that we have the data coming in. We do. Now what do we need? Okay, we've got a lot of stuff. We want the material equals still, we want the age after 1960, and we want either Chicago or New York City. The simplest way to do this may be to subset twice, right? So if we do, let's call it location is subset the sky data frame where we have city equal to Chicago, or which is a vertical line, so I'm using that's right above the enter key, right? And then I want New York City, and let me just do head location to see if I am. Oh, what I forgot was the city equals on the second one. The or works between. I have to do a full true false or full Boolean comparison. So I need city equals Chicago or city equals New York. I can't do city equals Chicago or New York City. Okay, and notice that in the city column, I am just getting the ones that I wanted. So this is working. Then, if that's working, what do I need? I need steel buildings, right? So what I can do is, let's call it final. Final, if I subset the location table so that the completed is greater than or equal to 1960, and material equals steel. Oh, that's lowercase steel. Okay, steel. And let me just look at a few more rows of this to see. And you can see that I have the material column is all steel. All of the buildings were built in the 60s or later, right? We have New York City, we have Chicago. So this works. The question is, can we do it all at once? Okay. Well, let's see if we can. All right, let me do this. Let me copy paste this down here. And I want final to be the subset. And I'm going to want to subset everything in here, right? So or, and then and then and. And the answer is basically yes, that works. Sometimes you'll feel like you want to put some parentheses around the ors. So we do or and then we do and, so it knows. It turns out that that does help R a little bit in closing the or in parentheses and then there are two ands. And again, this helps it understand the logic of what distributes across what. And these logic operators inside R, they aren't as clearly defined as maybe we'd like them to be. But again, parentheses around logical operators will help it. It'll do the logic inside the parentheses first and then do the logic outside the parentheses. So that's a way to get it all at once, although I did start with double subsetting, okay? And then what do we want? We want a density plot, okay? So let's try this. Density of final, but I want to plot the density of final. Oh, but final is a data frame, right? So what I need to do, I need to do final $height. Okay, and anybody who's seen a histogram will notice the similarity here. The density plot gives a little more information, all right? And so these are the heights of the skyscrapers. You see a lot of them are between 100 and 200 meters tall. There were plenty that were taller than 350 meters, which we subsetted for, right? Um, oh, that was earlier when we were subsetting for 350 meters. We're just getting newer than 1960 in steel. Um, all right. And so the density plot, which we will talk about more later, is very similar to the histogram, okay? And to see how similar they are, we can do histogram of final $height. Okay, and we have this breaks equals 10, I think. If we want a few more bars, we can increase the number of bars by increasing the number of breaks. Sometime at some point there comes too many bars, and we start to chop it up into too small. The intervals along the x-axis are too small, but if we don't have enough, we get these very clunky, big intervals along the x-axis, right? And again, this is one reason I like the density plot. We can still see the bell shape just like we can in the histogram, right? And we see the detail very easily without having to play around with the breaks equals number to get, the baby bear just right, not enough bars in the histogram, too many bars in the histogram to find the right number of breaks to have it look to have it show us the right information can be difficult. We'll use both, but it turns out that, yeah, the density plot is extremely helpful a lot of times. And that's it. That's a quick overview in one video of the basic things that we need to be able to do in R in statistics.